Alright, P3 day 1 is radicals and rational exponents. And so for day 1, we're going to evaluate square roots, simplify expressions of the form of the square root of a squared, use a product rule to simplify square roots, use a quotient rule to simplify square roots. Alright, so the definition of the principal square root, it says in general, if b squared is equal to a, then b will be the square root of a. The definition of the principal square root says a is a non-negative real number. The non-negative number b such that b squared equals a, denoted by b is equal to the square root of a, is a principal square root of a. So what it's saying is when you take the square root of a, when we're talking about the principal square root, we're going to look at the positive answer. And so let's evaluate this. So we get the square root of 81. Now most of us know the square root of 81 is equal to 9. But what if we didn't? Okay, so we can use our factor tree that we did back in middle school in geometry, and we can say what multiplies to give me 81? Well, most of us would say 9 times 9, and then what multiplies to give me 9? 3 times 3, and what multiplies to give me 9? 3 times 3. Now, we're looking for the square root of 81, and when we're talking about algebra and we say the square, we're talking about the number 2. Okay, so if I'm looking for the square root of 81, I'm looking for 2 of a kind. And so I go through here and I see I have a group of 3s here. There's 2 of them in there, so I'm going to take 1 out to represent that group. And the same thing here. I'm going to take another 1 out to represent that group. And whatever I take out, I multiply together, and there's our 9 that you already told me the square root of 81 was equal to. Alright, now b, the only difference between a and b is on b it has a negative in front. Well, that's like a negative 1 times the square root of 9, so we're going to keep it as negative 1 times. And what is the square root of 9? Well, it's 3, so we get negative 3. And then c says we're taking the square root of 2 things being added together. You have to combine what's under the radical first, so we're going to have to add the 36 plus 64. Even though both of them have square roots, you cannot take the square root of anything that's being added or subtracted. So you have to actually perform that operation. So we get the square root of 36 plus 64 is 100, and most of us know the square root of 100 is 10. Alright, so simplifying the square root of a squared, it says for any real number a, the square root of a squared is equal to that absolute value of a. In other words, the principal square root of a squared is the absolute value of a. So it doesn't matter if what's underneath there is going to be positive or negative, then it's going to always come out to be positive. So let's simplify. The square root of 5 squared, well, it's going to be equal to, it's equal to, the square and the square root cancel, and we're going to take the absolute value of what's underneath there. So remember, absolute value is always positive because it tells us the distance that number is from 0. And then b, the square and the square root will end up canceling, so it's going to be the absolute value of that negative 5, which is also positive 5. Alright, the product rule just says if we have 2 things that are being multiplied underneath a radical, we can separate them and put them both underneath that radical. Or, what we'll see more of, if they're already separate, we can put them together underneath the same square root symbol. So simplify the square root of 75. So we could separate this if we knew a perfect square that would divide in evenly into 75. But I think the easiest way to do this is just go ahead and do our factor tree. So remember your rules though to help you figure out what will go into a number. If it ends in a 0, it's divisible by 10. If it ends in a 5, it's divisible by 5. If it ends in an even number, it's divisible by 2. And if all the digits add together to be a number divisible by 3, then that number is divisible by 3. And what I mean by that is if you take 75, the 7 plus 5 equals 12, which is evenly divisible by 3. So therefore 75 is also divisible by 3. But it ends in a 5, so we also know it's divisible by 5. So either way, I see it as 3 times 25. And we're going to keep going to our prime numbers. 3 is prime, but 25 is not. It's 5 times 5. And now 5 is prime, so all numbers on that line are prime. So square root, remember we're looking for 2 of a kind. I have a pair of 5, so I'm going to take 1 out. And this 3 does not have a pair. He's by himself, so he has to stay under the radical. And so we get square root of 75 is equal to 5 square root of 3. Now, B, it says we could take the square root of this and the square root of that and then multiply them, but a lot of times we're going to be doing our factor tree several times when we do that. So on these, I like to go ahead and actually multiply them together first and then do my factor tree one time. So the rule says if I have the square root times the square root, that's equal to the square root of what's underneath being multiplied together. So 5x times 10x underneath my square root, which is the square root of 5 times 10 is 50, x times x is x squared. So now I'm going to come over here, I'm going to do my factor tree. I'm looking for square root of 50x squared. I'm going to start with my number. 50 is divisible by 10, so 10 times 5. 10 is 2 times 5, and 5 is prime. 2 is prime, so now those are all primes. But then I have x squared, and remember that exponent tells us how many of a variable we have. So we know it's going to be x times x. We're after the square roots. We're after 2 of a kind. So I have a pair of 5s, so I'm going to take one out. I have a pair of x's, so I write it down once. But I got this lonely little 2, so it has to stay back underneath that radical. And so we find that this answer is 5x square root of 2. Now sometimes you'll see this written as 5 square root of x. 5 absolute value of x square root of 2. It's the same answer, guys, okay? It's just because it's saying, well, you know, x could have been a negative number, and therefore when we pull it out, it would have to be that absolute value of it. Don't worry about it. If it has that absolute value symbols around it, it's the same as the other way. The quotient rule just says, hey, if they're being divided together, so the square root of a over b, then we can separate them as the square root of a over the square root of b. Or vice versa, square root of the top over square root of a bottom, then they can do it as the square root of the whole fraction. And so here we see on A that 25 over 16 I can't divide it, I can't reduce it, but I'm taking the square root of it. But I recognize that 25 and 16 are both perfect squares. So I can rewrite this as the square root of 25 over the square root of 16. And then what is the square root of 25? Over what is the square root of 16? And so that doesn't reduce, so there is my solution. Now on B, we could work out the numerator. We couldn't do anything to the denominator, and then we'd have to try to put it together. But remember, just like with the multiplication, when I have square root of two things separate, I'm going to go ahead and put them together. So this is going to be the square root of the top over the bottom. And then because they're both underneath that square root symbol, we can go ahead and divide them out, like what we were doing in one of the previous lessons. So I have the square root of 150 divided by 2 is 75. X cubed divided by x, remember you divide, you subtract your exponents, so 3 minus 1 is 2. And then we're going to go through and do our factor tree. So we're taking the square root of 75x squared. 75 is 5 times 15. 5 is prime. 15 is 5 times 3. 5 and 3 are both prime. But don't forget you have this x squared. The exponent tells us there's 2 of them. We're after the square root, so we're looking for 2 of a kind. So I'm going to take out a 5. I'm going to take out an x. But we got this lonely little 3 that's got to stay under the radical. And so we find that this is equal to 5x square root of 3. And that is the end of P3 day 1. So we will continue P3 day 2 on our next class day.